Planetary groups the structure blocks of our enormous area are never again as they used to be a stunning 771 trillion. Nearby planet groups have strangely vanished, leaving the logical community bewildered. What follows is downright incredible. From the profundities of space, new elements have started to surface, convincing us to uncover the truth behind the sudden vanishing of 771 trillion planetary groups in our tremendous universe. Might there be an association between the disappearing nearby planet groups and these mysterious specters from the universe? Join us as we set out on an excursion through the unfurling infinite secrets of evaporating stars. North of 771 trillion nearby planet groups have disappeared, and a disrupting peculiarity has risen out of the vast void. We will dig into the possible clarifications behind the vanishing of planetary groups and examine the presence of this confounding vast peculiar ity humankind has burned through thousands of years, understanding concepts like science and arithmetic which help us grasp our spot in the universe and the essential idea of Earth. Despite the fact that the center remains a mystery, one key thought is that matter doesn't simply vanish. It changes comparably when a star detonates and vanishes. Its material disperses across the universe, persevering in a different structure. This raises an interesting secret in space: the disappearing of stars from our night sky. Right away, this probably won't appear especially amazing given the endlessness of the universe. Stars can disappear unexpectedly for different reasons, like reaching the finish of their life or getting maneuvered into a huge substance like a black hole. Anyway, what makes the situation confounding is that it's not only a couple of stars vanishing. There are innumerable stars in excess of 700 trillion that have strangely disappeared, leaving cosmologists confounded about how they could have flickered out of presence so unexpectedly. While a couple of vanishing stars can be made sense of in a universe as immense as ours, the disappearing of many trillions, particularly those that aren't approaching the finish of their life cycles or undermined by outside forces, presents a totally unique issue. Luckily, a gathering of devoted researchers is enthusiastically attempting to disentangle the secrets of the universe. Beat Rick Volume 50 from the Nordic Establishment for Hypothetical Physics in Sweden sheds light on their endeavors, explaining that their undertaking, known as VASCO, is a critical one. Their essential objective is to identify a star that has remained a constant presence in the night sky for as long as human memory and available records can recall, only to evaporate unexpectedly without a trace. Even the most advanced telescopes have neglected to identify any remnants of such stars. A state rule highlights that this isn't just an unusual pursuit. The VASCO project has been active since 2017 and has gathered extensive attention. Each member is driven by their unique inspirations to participate. The group recognizes that certain parts of the universe remain eccentric because of tremendous distances, making it challenging to inventory each heavenly object with absolute accuracy. However, they maintain their trust in the capability of finding a particular type of star out of nowhere, disappearing from the night sky, a peculiarity that has not been documented before. A state our Underly finds that while variable stars exist, their changes usually happen over a period of years. In contrast, a mission is to find a star that changes from unflinching stability to complete vanishing, a discovery that might actually open new frontiers in the domain of physics. You may be wondering, is it really possible for a star to vanish without warning? The answer is yes. For instance, there was a star that space experts firmly observed for a lengthy period crossing 20 years until 2019. This star drew their interest in part because of its amazing gem-blue brilliance then. Out of nowhere it evaporated from there. Perceptions Andrew Allen, a doctoral student specializing in astronomy at Trinity College Dublin, fastidiously inspected and rethought the data. The winning theory suggested that the star had gone through a cosmic explosion, blast changing into a black hole. However, there were no perceivable indications of a cosmic explosion event or the expected consequence. Moreover, there was no noticeable black hole. Considering the delay between observations, it appeared to be deeply unlikely that such a dramatic event could have slipped through the cracks. Assuming for sure the star had progressed into a black hole without any cosmic explosion activity, it would present a situation of disappearing without the usual grand show, a peculiarity that has left space experts searching for answers for an extended period. Pieces of evidence pointing to such events date back to 2009, when a star which had earned attention from various telescopes seemed to be approaching a peak. The star underwent an unexpected change into a black hole before researchers could fully grasp the complexities of the process. While substantial proof remains elusive, this event left space experts in a state of puzzlement. Equally critical is the cooperative effort of various research groups, including those mentioned earlier, in compiling extensive star catalogs and their qualities. These catalogs enable cosmologists to access star data online and conduct broad comparisons. The findings have been both encouraging and shocking. As one scientist pointed out, they have identified various short-lived drifters that momentarily appear in one image before vanishing, comprising most of their discoveries up to this point. However, there are, on the other hand, different peculiarities that defy immediate classification and assessment. Of some of these temporary trends ruled out possible outcomes like M-dwarf flares or nova events. Expanding on this, a winning idea among some space experts is that the vanishing of these stars might be connected to the way light navigates the immense field of the disappearing stars universe. Imagine having a light source in your room and then leaving it until it disappears. Now, expand the distance across galaxies. This raises the essential question of how we can see anything at all. The answer lies in the fact that the countless light beam transmitted by these stars take an extraordinarily long time to reach us. Even when they finally arrive, they blend with the beams from our sun, enhancing their visibility in our night sky. As a general rule, the light we see is often several billion years old. In the case of our sun, which is relatively close, its beams still require around 8 minutes to reach Earth. When we apply this to stars located light years away, the age of the light we see becomes strikingly clear. This seemingly fast vanishing of stars may be a consequence of the tremendous age of the light we observe. Despite seeming instantaneous to us, the star could have stopped existing some time ago, and we are only now noticing its absence. This also integrates with the idea of stars going through extended periods of brilliance followed by fading until they reach a point where they are no longer perceptible. It's a perplexing thought, and while challenging, these questions should be raised to reveal the truth behind these peculiarities. Some people are drawn to investigating Dyson spheres and other more phenomenal potentialities within these speculations. For space experts, one notable theory concerning disappearing stars involves pondering the role of extraterrestrial creatures. You might wonder, how could extraterrestrial creatures cause stars to vanish? The answer doesn't lie in causing stars to evaporate, but rather in the intriguing possibility that these enormous divine giants may be used for their purposes. Have you ever come across the concept of a Dyson sphere? While it currently resides in the realm of science fiction, it envisions a situation where advanced extraterrestrial civilizations, or even rare occurrences on Earth build a specific uber structure surrounding a star. This superstructure serves as a means to capture and harness the star's energy on a colossal scale effectively, transforming the star into a titanic energy source or even an impressive instrument of force. This concept bears a resemblance to the situation portrayed in Star Wars: The Force Awakens, where the Star Destroyer base harnesses a star's energy to destroy several planets of the Republic. However, the practicality of such an explanation faces significant obstacles at the outset. The existence of extraterrestrial life remains unconfirmed. Moreover, the realization of a fully functional Dyson sphere, even around a relatively humble star, would require an extensive amount of time and a level of technological refinement that surpasses our current capabilities. When we consider applying this idea across more than 700 trillion stars, it becomes a monumental cosmic undertaking with questionable probability. Regardless, this idea, the great nothing, still maintains its advocates. So where does this leave us? The answer is that we are left without conclusive answers. What we cannot deny is that something exceptional is unfurling in the universe, prompting the vanishing of stars from our perceptions and view. This cannot be excused as a random event, as we have noticed the obvious absence of various stars. The central question that remains is what is causing such a significant number of stars to disappear within such a short range of time. This is exactly why people and associations from assorted disciplines are focused on unraveling this mystery. Finding answers to these questions might actually give us a deeper understanding of the universe. If similar peculiarities arise in the future, we might be better prepared to quickly unravel their causes. While the mystery of star vanishing continues to confound us, something novel has recently emerged from the depths of the universe. Researchers have accidentally discovered huge voids in space that exceed our initial assumptions. These voids include scales that stretch from the solar system to the Milky Way. The universe is made up of such shortfalls, far-reaching regions where divine entities are markedly absent. Among these, one exceptional void stands out: the Boötes Void, frequently referred to as the Great Nothing. When you gaze toward the night sky, it often appears as though there is an immense, evenly distributed region of stars. However, in specific regions like the Boötes Void, things are very different. These districts contain very few divine objects. Essentially, the universe has a remarkable construction: long strings of dark matter winding through galaxies and groups of galaxies with huge voids in the middle. The Boötes Void has a diameter of around 330 million light years, located near the Boötes cluster of stars and roughly 700 million light years from us. Initially, this void had only one galaxy. However, since its discovery, we have found a couple dozen more. The average gap between these galaxies is around 10 million light years, which is multiple times greater than the distance between Earth and the Andromeda Galaxy. This difference becomes clear when we compare it to our nearby cosmic region, the Virgo supercluster. The Virgo supercluster is smaller, around 110 million light years in diameter, and is home to more than 2,000 galaxies, including our Milky Way. To give you an idea of the enormous emptiness of the Boötes Void, the astronomer Greg Aldering once said that if our Milky Way were at the center of this void, we wouldn't have had significant awareness of other galaxies until the 1960s. In comparison, the Milky Way has around 24 neighboring galaxies in a region just 3 million light years across. Taking into account the size of the Boötes Void, it should theoretically hold around 10,000 galaxies based on the average distances between galaxies. Shockingly, we've only identified 60 galaxies within this gigantic void, making them the loneliest galaxies out there. The Hubble Space Telescope even captured an image of one of these galaxies, MCG plus 01020, a twisting galaxy dwelling in the Boötes Void. The European Space Agency has described it as the loneliest of galaxies. How it ended up so isolated remains a mystery. In the image you can see 3 stars in the foreground, all from our Milky Way. All the other things that appear as points of light are distant background galaxies resembling a multitude of little organisms in a drop of water. How do these voids form? Computer simulations have shown that smaller, more normal voids result from the gravitational pull of galaxies, bringing them closer together and leaving empty spaces behind. However, this explanation doesn't apply to the Boötes Void, as there simply hasn't been enough time since the universe began for gravitational forces alone to clear out such a vast space of this enormous size. This leads us to the Big Bang Theory. When most people imagine the universe's expansion after the Big Bang, they probably envision galaxies spreading out, evenly escaping from each other. However, a more complex design reveals itself. When we examine the universe on its grandest scales, it's like trying to fit billions of light years into a computer screen-sized cube. We should rewind the universe's clock back to its early moments shortly after the Big Bang. At that time, the universe was a highly compacted area of intensely hot plasma. Despite being mostly uniform in thickness, there were small variations or quantum fluctuations in space-time. As the UN expanded, these small variations in matter density became more articulated. Accordingly, areas with higher and lower matter densities emerged on large scales. Fast forward 13.8 billion years from the Big Bang, and we can see how these minute deviations in the beginning of time transformed into the massive structures we see today.